Hey everyone, this is Algebra 1 with Mr. G. We're looking at 11-3 simplifying rational expressions. This is the lesson where I asked you guys to go through the Ed puzzle and fill in the guided notes, so examples 1, 2, 3, and 4. And in class, I went over a few different examples. What I'm actually going to do today for this part is I'm going to go over the questions that are graphing questions for the second quiz of chapter 11. And I'm going to go over the same questions that I did for ID1 and ID2. So the one on ID1. So question 5. ID number 1. The question said, graph the function of f of x equals 3x squared minus 3x minus 6 over x squared minus 2x. Now in class, I went over some of the different examples, but either way, I said, when you want to solve these, you want to simplify as much as you can. The first thing that we learned in chapter 9 was if you have a quadratic, like you have up here, in this case it's a trinomial, you want to try to find a GCF before you do anything else. Here, the GCF is 3, because there's a 3 here, a 3 here, and 6 is divisible by 3. So when I factor out a 3, it's not going to disappear. I'm going to write it as 3 times x squared minus x minus 2. Then we're going to try to factor the bottom as well, and what those two have in common is an x. So I'm going to write this as over x minus 2. I'm not done yet. I have to factor again. What are the factors of negative 2 that give me a sum of negative 1? And that is, hopefully you said it by now, x minus 2 and x plus 1. And I know that because, again, if you need a reminder, you should try to set up that x chart or that x table and say, what are the factors of a times c that give me a sum of b? In this case, a times c is going to be negative 2, because remember, you're looking at the modified one, the simplified one, and then the b value is negative 1. Well, the factors are negative 2 and 1. That's where I'm able to put this factor here and this one over here. My a value is just 1, so I'm able to factor straight into the factored form. Okay, so now that I have this, now I'm going to try to cancel things out. X minus 2 are both terms that I can factor out because they're being they're factors. So they're terms that we're multiplying. 3 times this times this. I cannot just cancel out whatever I want. So I can't say, oh, there's an x here, there's an x here. We can't do that mathematically. That's not allowed. So my simplified version is going to be 3 times x plus 1 over x. But what do we notice? We cancel out an x minus 2, so we're going to use that in a little bit. Don't forget about that part. So what do we know? We know that the horizontal asymptote is always going to be a y equals something. So we're going to write it as y equals. In this case, we have to look at the leading terms. The leading terms are 3x squared over x squared. Are they equal? They are. There's a 2 here, there's a 2 here. The degrees are equal. So in that case, I'm going to look at the leading coefficients. 3 over 1. There's a 1 right here. Let's just assume that it's 1. So in this case, I'm going to write y is equal to 3 over 1, which is just 3. My vertical is going to be x equals, and this is where we set our denominator equal to 0 and solve for x. In this case, our denominator, the simplified one, is the x over here. So we're just setting that denominator equal to 0. And thankfully, I don't have to do anything else because I already solved for x by doing that. Now let's look for an x-intercept. Remember that for the x-intercept, you set y equal to 0. There's a mistake that I often see with students, and they forget that this equation right here is their new equation. So if writing out y equals the new equation, then go ahead and circle that so you don't forget to always go back and reference your work with this equation. So now we're going to continue. We have this equation, right? And we're going to set the y equal to 0 and solve for x. 3x plus 1 over x. You want to move this x right here so that we can just focus on the numerator. And by doing that, or the way that we do that, is we're going to multiply by x. This leaves me with anything times 0 on the left side is just 0. So what we're really doing is just setting the numerator equal to 0 and solving. I have to move the 3. I can factor it back in, or I could just divide both sides by 3. This leaves me with 0 equals x plus 1. Subtract a 1, subtract a 1. So what is my x-intercept? My x-intercept is equal to negative 1. Let me go ahead and write that here. So that's the x-intercept. Like we said, vertical asymptote here, and the horizontal asymptote here before we forget. All right, now let's go for the y-intercept, if there even is one. We never know if there's a y-intercept or an x-intercept. But the easiest way to tell if there is a y-intercept is to look at your vertical asymptote. This vertical asymptote, x equals 0, means that it is on the y-axis, meaning I have an asymptote on the y-axis. If I drew this out, I would have an asymptote that cuts through the y-axis. So that means that my hyperbola can never cross the y-axis. So would I have a y-intercept? I shouldn't, because it's never going to cross the y-axis. So in this case, we're going to say none. Even if I showed you this mathematically, it would look like this. Y equals 3 times 0 plus 1 divided by 0. Anything divided by 0 is undefined. So again, we don't have one at all. Now we're going to move on to the last thing. We're going to look at whether or not there's a hole. And in this case, there is one. The hole is found by seeing what we simplified. What x value did we cancel out? We canceled out an x minus 2. So we're going to set an x minus 2 equal to 0 to find the x value. Add 2, x equals 2. But we need to find the coordinate overall for this one. So we're going to plug it back into the simplified one. Y equals 3 times 2 plus 1 over 2. Solve. 2 plus 1 is 3 times 3 is 9. 9 divided by 2, which can leave us 9 divided by 2, or the exact decimal is 4.5. So now let's actually make a graph with this information. I'm going to draw my xy coordinate, or xy axis. In class, I said that if you have an asymptote, and if it makes your life easier, go ahead and draw out those asymptotes. That way you're not crossing those lines. I know that I have a vertical at x equals 0. So here's my vertical asymptote, and then a horizontal asymptote at 1, 2, at 3. So I'm going to draw my line right there. Perfect. All right, so now let's graph it using our black marker here. I've got an x-intercept at x equals -1 and y equals 0. So when y is equal to 0, I have a point right here. And then I have a hole at 2, 4.5. So I'm going to 1, 2, somewhere around here, just somewhere between 3 and 4. And then all I have to do is find one extra point. So make an XY table. I'm going to plug in -2, and I'm also going to plug in 1, because these are numbers that are to the left and to the right of the vertical asymptote. When I plug in -2, y equals 3 times -2 plus 1 over -2. -2 plus 1 is -1. That gives me -3 over -2 is positive 3 over 2, which is 1.5, 1.5. Again, where's -2? Where's 1.5? Somewhere around here. Last one, whoops. When I plug in a 1, this becomes y equals 3 times 3 plus, 1 plus 1 over 1. This should be an easy one, because this is going to be 3 times 2, which is 6. 6 divided by 1 is just 6. So I'm going to go to my 1, 4, 5, 6. I have a point right around here. And then just go ahead and draw your lines that get ever closer to the asymptote, but don't cross it, and don't forget the arrows as well. Okay, so that's question number 5 from ID 1. And this is basically the lesson that we learned, and a little bit more in class when I went over this. Looking at ID 2. Question 5, ID 2. In this case, you have f of x equals -3x squared plus 9x minus 6. And the exact same thing is going to happen here as what we did before. X squared minus x minus 2. Okay, I'm going to try to factor the top one, the numerator. I'm going to take out whatever is the GCF. I have a -3 here, I have a positive 9, and I have a -6, which means that they're all divisible by -3. Take out a -3, you're left with x squared minus 3x plus 2 over, what are the factors of -2 that give me a -1? Well, this should be x minus, let me think about this one. X minus 2 and x plus 1? Yep, that's what it is. Again, factors of -2 that give me -1 should be -2 and positive 1. Perfect. So now we're going to go ahead and factor the other one. What are the factors of 2 that give me a -3? Should be -2 and -1. So I'm going to factor the top one even further into that. And now I'm going to try to factor as much as I can. Oops, messed up somewhere. That's a +1. Okay, everything else looks fine. Cancel what you can. X minus 2, that's a factor. X minus 2, that's another factor that you can cancel out. This leaves me with my new equation. Y equals -3, x minus 1, over x plus 1. So now, let's go ahead and fill in all the information that we need in order to graph this correctly. the first thing I should try to find is a horizontal asymptote, and it looks like we have equal degrees. I went over that already on the last problem. So you're going to set up your equation and say leading coefficient over leading coefficient, that's a negative 3 over 1. Therefore, horizontal asymptote, let me just double check, yeah, is y equals negative 3. The next one, vertical asymptote, you're going to set your denominator equal to 0, x plus 1 equals 0. We're going to subtract 1, and we end up with x equals negative 1. And I'm going to go ahead and box these just so I don't lose sight of where everything is. Y equals negative 3. X equals negative 1. And then let's go to the next one. X-intercept. How do I find that? Say y equals 0. 0 equals negative 3 times x minus 1. And remember what I said for the last one. You end up just setting the numerator equal to 0. Was it here? No, it was right here. You end up setting the numerator equal to 0 and solving for that. And remember what I said for the last one for the x-intercept. You end up setting just the numerator equal to 0. So that's what we end up just caring about. Let's go ahead and do that. Here in this case, we're going to leave 0 equals negative 3 times x minus 1 equal to 0. And then go ahead and solve this one. I'm going to divide by negative 3. Divide by negative 3. We end up with 0 equals x minus 1. Get rid of the parentheses because we don't need those anymore. And then we're going to add 1. Add 1. So therefore, x equals 1. That's my x-intercept. You should write it as a coordinate though. X-intercept says that when x is 1, y is equal to 0. That way when you look back for a coordinate, you could say, well, there it is. It's not that hard to find. I already have one that I solved for. The y-intercept, I'm going to go ahead and write that over here. Y-intercept. Looks like our horizontal and our vertical are not at zeros. So I have to have a y-intercept and an x-intercept. For this one, same thing. Y equals negative 3, but set the x is equal to 0. 0 minus 1 over 0 plus 1. This leaves me with negative 3 times negative 1 is 3 over 1. You have a y-intercept at 3. When x is 0, y is equal to 3. And the last thing, ask yourself, did we cancel anything out at in one of the beginning steps? In this case, we did. We canceled out x minus 2. And we're going to set that one equal to 0. And then solve for x. X equals 2. Plug it back into the simplified to make your life easier. Y equals negative 3 times 2 minus 1 over 2 plus 1. 2 minus 1 is 1 times negative 3 is negative 3. Negative 3 divided by 3 is going to give you a negative 1. So 2 comma negative 1. Then I'm going to graph this as my final step using all the information that's been solved for. I know that I have a horizontal at y equals negative 3. 1, 2, 3. Oops, sorry. Y equals negative 3. X is equal to negative 1 for my vertical. Let me redo that one. There we go. Okay, and now let's go ahead and plug in the coordinates that we found in the blue marker. The first one that we have, we could easily spot is the x-intercept. When y is 0, x is 1. So when x is 1, y is 0. I'm going to go ahead and plot a point right here. Then we're going to look at the y-intercept, 0, 3. So that's when x is 0, you're going up to 3. And then the other value that we found was at 2, negative 1. So when x is 2, y is negative 1, open circle. And then we can go ahead and graph these values and make sure that they don't cross the hyperbola. I've got 3 points here. All I really need is just one more point just to kind of prove how this looks. And I'm going to plug in a point that's in this area of the x-axis to the left of the vertical asymptote. So I'm going to plug in negative 2 to my xy chart. Negative 2, let's look at the simplified. There it is. Y equals negative 3 times negative 2 minus 1 over negative 2 plus 1. The numerator is going to end up being negative 3 times negative 3, gives me a 9. Negative 2 plus 1 is negative 1, which equals negative 9. Negative 9. So when x is negative 2, I'm going to have a value at negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It'll be somewhere down here. But at least then I can graph a general idea of what this is going to look like. And those are my two graphs. On the actual quiz, the graph actually goes down to -9. It's a lot easier to graph than it was here.